Today we'll solve some previous year question asked on JEE Mains based on our previous lecture. So this question was asked in 2023 April 8. So before solving this question, one must have a clear-cut idea about some standard uh, limit involving some standard trigonometric function and logarithmic function. So here we are going to use this formula. Here we are going to use some formula that I am writing here. And another one is okay, here it can be A or it can be A. So it is limit. Then it will be okay, but one condition will be so we are going to use these two standard result to solve the above question. Okay, so let us see how we'll proceed this one. So the 1 minus cos square theta is equal to sin square theta. So I will replace this by sin square 3x. There is in our question 3x is given in place of theta. So I replaced 3x as theta. Later I'll write cos cube 4x. It is already in sine form. So if we it is 5 So if we see carefully, then it is we are going to relate this with this standard result. Okay, so in order to apply this formula, we have to make sure that in denominator we have f of x. Okay, so if we want to relate this with this formula, then you can clearly see that here 3x is our required f of x. So we have to make that f of x in the denominator as well. So like that, if we relate or this denominator sine cube 4x with this formula, then you can clearly see that f of x required f of x is 4x. So we have to anyhow create f of x in the denominator of this, okay, function. And if we relate this one with this formula standard result, then we can clearly see that our required f of x for this to apply that this result, it is 2x. 2x is our required f of x. So let me write separately. Here is for f of x is here, and it is our f of x. Okay, so here 3x is our f of x. Okay, so identifying f of x is the first step of solving this question that we have already done. Now we'll try to make that in the denominator. Okay, one more thing we have to notice that here it is not sine of f of x, it is sine square f of x. So we have to make our denominator f of x square. In okay, we have to make whatever the f of x is, we identify f of x, then we divide that with the square of the f of x. So it will be limit x tends to 0, it will be sine square 3x. So I will multiply f of x square in the numerator and in the denominator. So it will be 3x square, and I will multiply here as well, that is 3x square. I will write the rest of function as it is. So here I will do, okay, sine cube of 4x is given. So I will multiply f of x cube in the numerator and denominator. So it will be 4x cube into 4x cube. So here f of x, the whole power is 5. So I will multiply f of x of fifth power in numerator and denominator. So it will be okay. Now we'll write it in some good format, or the desired format is, it will be, okay, 3x square is good. So it will be sine 3x by 3x whole square divided by it is cos cube 4x. Okay, one thing you can observe here, that I am not doing anything with this function. Why I am not doing anything? Okay, because when x tends to 0, this function will give me a non-zero value. Okay, so I don't have any issue with this function. Okay, you can clearly see that when x tends to 0, this function will tend to 1. Okay, So now we can see that this one, if we closely observe this one, then it is sin f of x by f of x is given, and f of x is our 3 of x, and when x tends to 0, this 3 of x tends to 0. So we can clearly see that we can apply this result. Okay, the f of, in the letter you can see that f of x is our 3x, when x tends to 0, f of x is 0, and that's why we can apply this result. Okay, then it will be, the limit of this one will be 1. Okay, and the limit of this one will be 1 as well. So if we apply here as well, then it will be 1. Here f of x is our 4x, and when x tends to 0, 4x is also tends to 0. So easily we can apply here as well. And here if we relate, then it will be our f of x is 2x, and when x tends to 0, 2x is also tends to 0. So we can easily apply the here. So the limit of this function will be 1. Okay, so now by using the algebra of limit, sorry, we can now write it here as this limit will be 1, this limit will be 1, this limit will be 1, this limit will be 1. So the rest of thing will be like 9x square into 1 divided by 1 into, okay, 64x cube into 1 divided by t will be 32x5 into 1. So now if we clearly observe, then it will be 9 into 64 into, sorry, x to power 5. I have denominator, I have x to the power 5. So I will cancel out this x to the 5. Then I will get rest of limit x tends to 0. I will get 32 2. So it will be 18. Result return will be 18. Okay. So if constant is given, if our function is constant, then x tends to 0, 5, whatever, the result will be that constant. Okay, limit of that constant function will be constant at any point, x tends to whatever point. So we got our result as 18. Now we'll solve another problem, a bit of tricky question it is. Okay, so the question is, it is given, it will happen, and question is 8 alpha plus beta will be what? Okay, so this question was asked in JEE 2022. Okay, first shift July 25th. So we'll solve this question. Okay, so before solving this question, we have to analyze the given data. So limit of this function when x tends to infinity, it will be 0. So we first check, we have to check what sort of indeterminate form is arising here. Okay, so it is related to something infinity by infinity, or infinity, sorry, infinity minus infinity. Then we'll first we will multiply and divide with the your negative sign. We'll take the negative of this expression and multiply and divide with this expression, then it will be. So I have just multiply by taking the negative of this expression in the numerator and denominator. So clearly I can see that here it is, okay, here it is a, here it is b, and a plus b, and it is a, and it is b. Okay, so it is a plus b into a minus b, so I can apply here a square minus b square, so it will be n square minus n minus 1. Okay, so it will be n alpha plus beta square. Okay, I will write the denominator part as it is. Okay, so I have opened the bracket in the denominator, so the it will be minus n alpha and minus beta. Now I will open this bracket and try to write the like terms. So now I will open the bracket first. So it will be, okay, 1 minus, sorry, it will be 1 minus alpha square n square. Okay, here this one I have taken n square common. Now I am taking minus n common from this one and this one. So I'm taking minus 1 common, so it will be 1 plus 2 alpha beta. So now the rest of are 1 minus beta. Now I'm taking n square out of this square root, so it will be n 1 minus 1 by n minus 1 by n square. Now I'm taking n common from this term, and this is term 1, term 2, and term 3. So I'll take common n, then it will be n just let me put a bracket so that, okay, so we don't have n in the this term, so we'll divide. Okay, now divide the n in the all terms in the numerator. So I will get 1 minus alpha square n, 1 plus 2 alpha beta n. So here n is divided by n, so it will cancel, and when n is cancelled, so we have 2 n square here, so we'll get another 1 n in the function. So here it will be 1 plus beta by n. Okay, so I got the rest of thing, that is okay. Now one thing I have to see here. Now if I put n, when n tend to infinity, the numerator will tend to infinity. Okay, when n tends to infinity, then this term will be 0. Something divided by infinity is 0, and this term cannot do anything. And when n tend to infinity, here n is given, so it will be infinity. And when n tend to infinity, this term we have some non-zero, like 1 minus alpha will get in the denominator, will result into 1 minus alpha. So ultimately what we are getting n tend to infinity. When n tend, okay, the limit of this function will be infinity when n tend to infinity. Okay, uh, at this situation, but we are given that when n tend to infinity, in our question we are given that the limit of this function is equal to 0. So so if we want that the limit of this function will be equal to 0 when n tend to infinity, so that is possible in one case, if the coefficient of this term is 0, that is equal to 0. So what are the required condition? That 1 minus alpha square have to be 0, which implies alpha will be plus minus 1. Okay, so it can be either plus 1 or minus 1. Then 1 minus alpha square will be equal to 0, and we'll still can say that the this term, this function will be equal to 0. So this is the required condition. Okay, if it will not 0, then when n tend to infinity, this function will tend to infinity. But that is not true. That is not possible, right? It is given that the limit of this function is 0 when n tend to infinity. So now we got two values of alpha. It is possible when n alpha is equal to 1 or minus 1. Now we'll see in denominator what happens when n tend to infinity. When n tend to infinity, I will get the denominator will be reduced to what? 1 minus alpha. Okay, let us suppose we have taken the value of alpha as 1. Then in the denominator will be, okay, 1 minus 1, it will be 0. So again, something by 0 will be what? Again it will tend to infinity. So we cannot take minus 1 as the value of alpha here. Sorry, 1. If we take the value of alpha 1, then the denominator will be reduced to 0 and the function will be equal to infinity. Okay, so we can clearly see that we have to take the value of alpha as minus 1. Okay, this is the final. Okay, now we take alpha, the value of alpha as minus 1. So but we have to ensure that the limit of this function is equal to 0. So when n tend to infinity, this term goes to 0, and as alpha we have taken -1, this one also 0. Rest of thing is this: if this term will be 0, then we'll get that what the limit of this function will be 0 when n tend to infinity. So at last I have to take that 1 plus 2 alpha beta have to 0. Okay, so 1 minus 2 beta is equal to 0, which implies okay, beta is equal to 1 by 2. So here I get the value of beta also. Then the question was to evaluate 8 times alpha plus beta. So I got the value of alpha and beta. Now 8 times alpha plus beta I have to evaluate. It will be 8. Alpha is -1 plus beta is 1 by 2. So it will be 8 into minus half. It will be -4. Okay. So let me revise this question once again. Okay. What is given and what we are doing. So it is given. Okay, like sorry. Okay, it is given. Okay, it is given that limit n tend to infinity, this function is equal to 0, and we have to evaluate 8 times alpha plus beta. So before evaluating 8 times alpha plus beta, we have to find out the value of alpha and beta. So we proceed by taking by multiplying negative of this expression. Okay, negative, we take the negative sign here and multiply and divide in the numerator and denominator. And in the numerator I can see that it is a clear cut formula of a plus b into a minus b, so it will be reduced to a square minus b square. And after getting the above expression, I open this up. Okay, a plus b whole square, I use the formula, and then i I have written okay separately. Okay, n square minus n something. Okay, it is the constant. In the denominator I have taken n common, and after getting n common I have divided with all terms of the numerator with n, and I get this one. But in our question it is given that when n tend to infinity, the limit of this function will be equal to 0. Okay, but when n tend to infinity, in this function we can clearly see that this term tends to infinity. Okay, it is a constant, so infinity minus a constant will be infinity. Now something divided by infinity will be 0. So this term will be 0, this term will be as it is written, and this term will be infinity. So when n tend to infinity, this function will be tend to infinity. But it is given that this limit of this function will be 0. So for that the coefficient of n have to be 0. So I equate 1 minus alpha square equal to 0, and I got two values of alpha here, that is +1 and -1. Okay, so now we'll check the what will happen to the denominator when n tend to infinity. When n tend to infinity, this term will be 0, this term will be 0, so root over of 1 will be 1, and 1 and minus alpha, this term will be 0. So when n tend to infinity, the denominator will be reduced to 1 minus alpha. And if I take the value of alpha as +1, then I will the denominator will be reduced to again 0. So something by 0 will be infinity again. So it will not be equal to 0. Okay. So in order to make this 0, it has to be a non-zero function, non-zero value, and this have to be a the value of this function have to 0 here. Okay, 1 plus 2 alpha beta have to be 0, and the denominator have to be a non-zero value. Then from here it is clear that alpha, the value of alpha will be -1, sorry, and this expression have to be 0 in order to the limit have for this Okay, so from here I get beta, the value of beta is 1 by 2. So if I put here, then I will get -4 as its answer.